Okay, I think we'll probably make a start. So thank you all for joining for another Value in Energy Data seminar. So just before I introduce the speaker, just a few housekeeping bits and pieces. Please turn off your camera and microphone. That's because mainly we'll be recording this event and that'll be uploaded later, so we can just focus on the speaker and his slides. But also, yeah, just keep in mind as well that we are recording this and it'll be up later as well. And shortly after, usually, the presentation. Finally, if you have any questions, then put them in the chat and we'll come to those right at the end. Okay, so let me give a quick introduction to our speaker today. Let me stop sharing my slides. There, that's off. Yeah, so Dr. Fei Teng is the Director of Education in the Energy Futures Lab and a lecturer in the Department of Electrical and Electronic Engineering at Imperial College London. He holds a visiting professor position at MINES ParisTech in France and PloyU in Hong Kong. And his research focuses on efficient, secure, privacy-preserving and resilient operation of future cyber-physical energy systems. He's authored over 80 scientific publications in leading power system journals and conferences. And his research is funded by the EPSRC, ESRC, Innovate UK, the Royal Society, EDF Energy, and the National Grid ESO. And so with that, it's my pleasure to introduce Dr. Fei Teng, who will be discussing work from his recent report on promoting energy data sharing through privacy protection. So take it away.
Yes, thanks, Steve, for the introduction and also invitation and organizing the event. It's really a great pleasure to share some of our recent work in this topic. And also thanks for colleagues for joining today. Before, should I also turn off my camera, Steve? How normally we work?
Happy to keep your camera on, yeah, if you share your slides. So it's, yeah, either it's up to you really. You can do either.
Share my slide. All right, so I assume everyone can see it, yeah?
Yeah, I can see that.
Okay. Let's start. Today I would like to just share one of some of the work we recently concluded in the basis of a briefing paper to looking at one of the challenges we believe for the future kind of digitalized power system, in particular in terms of accessing high resolution or high quality energy data. Basically, what we have been looking in this particular report and also today's presentation is to look at what really the concerns from consumer perspective. There are a lot of discussion on privacy, but what that really mean for the consumers for electricity systems, and also if that there are genuine existing of these concerns, how and what kind of techniques we can apply to really mitigate such this concern, so that we can wider access some of the energy data. So to start with, I think since you are here and we should have a consensus that digitization is a key element or key enabler for our future zero carbon energy systems. It will fundamentally, radically change the way that we produce, we exchange, we consume the energy. The key question is basically to understand what is the best way and how to capture, store, managing, analyze, and make use of this big data to support the system operation planning and enable the decarbonization at least costs. In terms of data, there are different various sources. It's mainly can categorize as either is from kind of operational data for system operators, the TSOs. This is particularly enabled by the rollout of PMUs in the different level of the networks. They're also growing transparent because of Transparency Act. We have growing data in the electricity market, including settlement or bidding data, and also last but not least, although I mean delayed for the rollout of a smart meter, but it will be a fundamental element in the future digitalized power grids for the consumer and suppliers data. Once we get this data, remember the word once, okay? We'll come back to that. Once we get this data, there are many things we can do to analyze those data to make use of it. One of the trend or say most development for the last 5 years is to use some machine learning algorithms based on those data. It can start from very predictive machine learning based on to understand what has happened in the past. It's mainly utilize some unsupervised learning programs to understand what, for example, demand response deliveries, what would be the response that has been delivered, or to classify the consumers for tariff design purpose. And based on this knowledge, we can also move a bit forward to see what will happen in the future, to move to the predictive machine learning to look at, mainly forecasting problem, for example, virus forecasting, that also be a fundamental part of our system operation at different levels. And then to make one step further, there are prescriptive machine learning, is mainly looking at decision making based on the information. What should we do? What would be to assist the humans to make decisions? Those are mainly utilized machine kind of reinforcement learning techniques like market bidding and energy network management. Those applications has been, growing significantly in the past years, conditioned on the data that we can access. Before we discuss the data, maybe I want to very briefly go to some of the applications we have been doing at Imperial. So one of the things that we have been looking at is by utilizing smart meter data, which is aggregated of consumption level, can we really understand more the consumers in terms of their device level consumptions? One example is it's a genuine need for for the distribution network operators and also for retailers to understand whether the at the household, whether they are electrical vehicle charging and also the charging profiles. So how can we get the charging profile from the aggregated smart meter data is one of the activities we have been doing. So in that basis, we look at the EV charging profile is very actually distinguished from other devices. It's generally significant in terms of the volume, and also the duration is consistent. By utilizing this characteristic, we have developed this very easy to use training-free algorithms to separate the electrical charging consumption into the total smart meter data. It has been performed very accurately. This actually is one of the challenges that WPD data challenges that looking at that's not organized by Steve, but that's more on feeder level instead of the household level. But that's a genuine need for industry. We are glad that we are getting second place in this challenge. And also we did a bit of work on try to estimate the baseline for demand response. Basically, no matter for settlement purposes or for prediction how much response we can achieve, we need to know how much the response has been delivered by the user. However, the challenge here is for a particular event, right? You can understand it, you have the measurement, either there is a demand response triggered or there is no demand response triggered. What we are really interested in is actually a difference, right? That's the changes of that's the responses that we are interested in. So that's really a challenging part to understand or to estimate what was the baseline, assuming this demand response event was not happened, and then we subtract the difference to as the response that delivered. Traditional approach has been doing more look at the consumer groups, try to find someone or group of people similar to the one that is under interest, and use their profile to predict the baseline of this particular customer we're interested in. However, there are two challenges. We say that one is really hard to get someone behave similarly all the time, because also that linked with second one, because most of the DR events really happens on the relatively rare or abnormal events. So although majority of time of the users are similar, but there's no guarantee they're going to be similar in these extreme events. So based on this concept, we instead of looking at to group consumers or look at one particular group of people, we pull all the data profiles of the consumer we have and use these techniques to basically create a synthetic people. I say statistically, this profile will be mostly the same as the people that we are interested in, and that profile can be used to estimate the baselines. So we have presented, we have kind of checked and verified this performance. It's performed very well, and we also expand this to a more, instead of deterministic, to say what would be the response. We also do a probabilistic given the very large variations in the single household level. So it's a probabilistic assessment. Another work I want to very briefly go through is we just conclude with natural good ESO to predict what the system inertia in the next 24 hours. As you may know that because we have large significant renewable or IBR inverter-based resources into the system to decarbonization, the system inertia will decline. Without proper management, we will face stability problems, right? So national grids have conducted or have, implemented two measurement screens for inertia, but for them to proper manage the inertia, they also need to know that ahead, not only real time. So this is where this work is carried out to look at the inertia prediction problem. So the outcome of the results is very promising. We reduced the forecasting error of state of models in the literature by almost 50%. We also extend this concept. Also, I believe this was the first model that to do probabilistic they had in inertial forecasting. So we will be able to provide not only the estimated inertial value, but also the risks associated with different numbers. Okay, I think that's all great, right? It's only a snapshot about the application we have been doing. There are a lot of more the colleagues worldwide have looking at this. And also there are significant development in the machine learning or computer science kind of society to help us to provide more algorithms that we can use. However, there are always a however, right? The question I want to pose, and also that's based on the experience we are doing in the past few projects, is can we really get the data we need? For research, they're widely open. In a sense that some of data we can source, but for a real world application, can we really get those data we need? Or say, can we get this data easily? The question is not. No matter you want to get the consumer data, then you have to get the consent and everything. Or when there are discussion on digital twin. If you want to do digital twin there, then kind of the whole system twin that's the promoting, and then everyone do not want to share their twin or their data, right? So how can we mitigate this? To answer this, we get back to the fundamentals to look at what really the concerns of sharing data. Can we mitigate that? In that context, this is more social science research, so we kind of borrowed existing expertise looking at the existing service. Surprisingly, actually, if you look at the service, majority of the users, consumers, let's focus on consumer at this moment, they are willing to share their smart meter data, although it's vary between consumers. However, in reality, if you look at how many of them are sharing, the recent data is actually 49% of them are not sharing half-hourly data, which is the most valuable for the operation, or 37% of them do not really know what they are sharing about. Okay, although the survey suggests they're waiting, but the reality is not the case. Another thing we have found out is in general, the smart meter data is considered less sensitive by the consumers than other type of personal data, including financial, location, and medical data. So this brings us to ask two questions. Yeah. So really, are they really making informed decisions when they select how they want to share their data, both in terms of whether the different options of resolutions and the sharing has been communicated well with consumers, and also are they really aware of implications of sharing the data? So do they know really what information embedded in the smart meter data, as the survey suggesting they think there are less information in smart meter data than other types of data? So to answer particular second questions, we look at what really be the information can be get from smart meter data. Okay, we need to separate now the data and the information. That's two separate things, right? But from the data, we can see, well, we would like to understand what would be the information. One technique we have mentioned is this non-intrusive load monitoring. We have been also ourselves have been working on that. We did a bit comprehensive survey or literature review on existing work about how the different time resolution of the smart meter data can be used to infer different level of devices. In this particular figure, you can see once we have the data is about 30 minutes or below, we can, with very high confidence, to infer or to separate many of these appliances, including cooking, heating, electrical vehicles, and so on and so forth. However, maybe the consumers may argue, okay, why we should concern about, I mean, the device level data, right? Okay, I don't care. People know I'm using microwaves at a particular time of day. But however, the behavior scientist has concluded that the activities of people at home is directly linked or directly drive the way they use appliances, which means to say the appliances information can be used to infer the activities and more. In that context, we look at really, I mean, more social demographic and the deriving information. How can we, whether they can be inferable? You can see here, when you have relatively higher resolution data, there are really a lot of information, more than just device, can be learned from smart meter data. In fact, if you have a deeper look at some of those information are exactly the same as medical, financial, and location information. Yeah, here I think it's fair to conclude we cannot treat smart meter data less sensitive than other data. But the reality is people think that is wrong, right? That is less sensitive. So we want to know what the gap it is. So we did a bit look at some of the surveys, and also we did one from ourselves. So actually we can conclude that majority of the consumers, when we think about their smart meter data, they're not aware what I have presented you, what information can be learned from the smart meter data. So when they make decisions, they don't know there the potential from smart meter data will know your income. Okay, and also that there another survey has provided that once they are provided this information, once they know what is the implication of data sharing, they will change the way that they share the data. The figure on the left, you can see that once they are informed the implications of data sharing, 90% of the users either cancel the data sharing or change how the resolution they want to share. So which is to say it's fair that once the kind of implication become more aware by consumers, we will have a risk about accessing some of the data, more and more risks. But on the other hand, we also find out that the one potential way to incentivize or to mitigate this risk is to provide some privacy preserving techniques. It has been clear that more than 50% of people are more willing to share if the data was made anonymized. Okay, this is a can be a preventive actions that the society can do to prevent once the awareness of data implications, smart meter data implications become more, we can mitigate the reduction of the people that are unaware to share the data. Then for the question becomes, how can we really provide a privacy preserving mechanism that's fit for our energy systems that can provide energy data sharing? Bear this question in mind, we look at a few options that has been promoted in general society for privacy preserving. Those include more traditional approaches that pseudonymization will remove the name or contact information of individuals, kind of unique identifiers, or aggregate to sum up some of the load consumption load, either by spatial or temporal purposes. Or there are some more recent advanced on the privacy preserving, including differential privacy and homomorphic encryption options. And of course, there are another two options that we have investigated. But the key here is we want to understand whether they are really suitable for our energy system applications. So in the briefing paper, there are more details in the briefing paper that we did a mapping, or we did a comparison to see how these different techniques potentially interact with energy systems. It was to point out that the traditional methods like pseudonymization and aggregation does not provide any guarantee on the privacy preserving. Okay, the problem that is once there are linked data sets from other data sets appear, they will there's not guarantee that we cannot identify individuals or disaggregate them. And for if you are looking at more homomorphic encryption and user demand shipping, those two options are kind of require significant investment so that we can run this algorithm in a local level, or you have to invest the storage devices to shipping your demand. So in general, the two most promising one we think for the energy data are, one is the differential privacy, which require the minimum change of the current framework, and also there are cases has been successfully applied for public goods, public information. Another one is federated learning, or let's say distributed data processing. This one require kind of radical changes of the way we manage the data, but in the long run, this is also potentially bring significant benefits. So these two are what I'm going to probably discuss a little bit more following on. Okay, to start with for differential privacy. So differential privacy is the technique that we adding noises to individual data so that by looking at the data set, you cannot identify a particular individual. The concept is very straightforward. If you are looking at one particular applications, we have a data set, and then we have one outcome, right? If one particular people in this data set have a significant impact on the outcome, and then there is also there is more likely that by looking at outcome, we can find out this person. Okay, for differential privacy, it's by adding noises into individually so that no individual in the data set would have a predominant impact on the outcome. In this way, by only looking at outcome of particular functions, you cannot reverse or work out whether individually in the data set or not. So this figure may be more clear demonstration if you have no noise or less noises. We're looking at first, let's looking at two data sets, E and E prime, right? Only thing different is we have one people are not included in one of the data set. Others are all the same. So if you look at outcomes without adding any noises, we can see that this outcome of these two data sets are very different. So this implies the higher risk, we will know particular person impact a lot on this outcome. By adding noises, it will be possible in the data set, it's possible to make these two data sets have very similar outcomes. In this way, we cannot really protect the individual, basically reduce the individual impact on the outcome so that also protect this individual. For application side, this differential privacy can be either based on the kind of expanded DCC functions. For example, if you're looking at smart meter data, allow them to add the data in kind of centrally before they shared with wider society. Or if we still want to keep what we are doing now, we can also implement this in the local level by adding the noise into smart meter data before sharing it. Both are achievable. And in a report, we focused on one case study to compare US census accesses and smart meter implementation. It was to note that US census is one of the first kind of public activities that utilize differential privacy to provide privacy, to maintain privacy for the users. And we're mapping that what would be the steps in both applications by utilizing different layers of privacy protection. And 2020 US Census has utilized the differential privacy. Then we have a question mark is whether it's going to be applicable for energy data or smart meter data as well. But of course, the differential privacy introduces a trade-off. As I mentioned, you have to add your noise into your data before you're sharing it. So that's going to degrade the quality of the data or accuracy of data. So then the question would be whether it is really still applicable for energy data where we do not really want to degrade too much of the benefit of data, right? So then we were commissioned by Superg Network to look at one particular case study is to see in the market environment how the differential privacy might impact the retailer. So basically, this is a access we we did for a simulated market environment where the retailer have to bid into the day-ahead markets and also balancing market to balance their position. And then the retailer will use forecasted consumer loads. The forecasting can be done either by utilize the system level data or using its consumer basis smart meter data. For smart meter data, you can also add different level of noises to look at what would be impacting economics by adding different level of noise into it. So in this particular case, if we start from the one, we look at two cases. One is we consider the risk, which is the orange one. There is a severe constraint for the retailer to manage. And another one is the blue one, which this is assuming the retailer is risk neutral. So in general, the conclusion are similar. It's just if you are more risk averse, you would prefer to have the data more. So we will focus just one of the cases to analyze. So if you look at the run on the very right, this is a case assuming the retailers do not have access to individual data, so they have to utilize the system level data to do prediction. While on the very left side is assuming that the retailer have all their individual consumer data, half-hourly data, and they can use that to do forecasting purpose. We can see there is a significant benefit for the retailer. While in between, we have tried to add different level of noises to maintain different level of privacy protection targets. We can see that it still even have a relatively strong noise addition. We have a still clear benefit to accessing the consumer data. Another funding we have is because the consumers have really heterogeneous preference, right? Someone are really risk averse, but someone are risk neutral or even don't care. So you can do one option you can do is you use the worst case privacy, you keep the most privacy, the highest level of privacy for everyone, right? You keep that. Another case is we consider different preference and you design it differently. Actually, differential privacy allow you to do that, and we can see that by considering the heterogeneous really bring a lot of benefits into by reducing the degradation of the value of data. Of course, the bigger question is yet to answer is what would be the right level of different privacy for individuals. This have to kind of considered in the economic incentive perspective. I will discuss that a little bit more later. So what we have been presenting is we still want to try to keep the current way of processing energy data, where it's basically you collect all the data in one single place and you process that as a single processor. However, this is really ignored one of the biggest development in the energy system, which is basically the edge device in computing communication devices in the local level. So if we would like to consider more abrupt changes or more radical changes about the way we process data in the energy sector, one option is to look at more local data processing with a coordinator. Instead of share the data to one place to process it, another option is we have local processing, only share information. So here is to say we have to be clear the difference between information or knowledge and data, right? It's not necessary to share the data to get the knowledge. You can process that data locally to share the knowledge instead, okay? Okay, time, okay. Fine, 5-10 minutes, we'll finish it. So one of the options that have been mentioned is called federated learning, because again, the traditional way of training your machine learning models is every user submits the data into a kind of cloud, and then we train a global model in a kind of centralized manner. Another option is basically look at, we have an additional layer, we have edge layer where they can actually train their local model. So the edge layer will train their local model based on their local information and only share the parameters of the local model so that they can coordinate the information, because the parameters is more informative in terms of your target, right? So that is really what, in a sense, that really matters for these particular applications. So in this way, we can also, I mean, on one hand, we can preserve the data in local and also share the knowledge in this sense. Give you one of the examples we are looking at for distribution network layer. We're looking at how we can use federated learning to do voltage forecasting. Okay, so basically here is we're assuming the consumers are not willing to share their individual smart meter data to support the voltage forecasting of the network. We compared two cases. One is the centralized case. This is basically assuming everyone are cooperative, everyone are willing to share. So we have the one processors have all the data and process that. We can get pretty good performance in terms of forecasting. But on the other hand, if each individual agent do not share their data, they only use their own data to do prediction, you can see the performance is significantly degraded. It's almost useless in this context for energy management. So this is how we can implement this kind of federated learning framework where each local agent will train their model locally, and then they will share the parameter into a central agent. They will processing basic knowledge to the single energy, and we can use the min to update the parameter, and then this can be converted back to share this information to local model, and then they will update again based on their own data. So in this case, we can see that we did a test that in this setting, while keeping the data locally, we almost can achieve the same performance as a centralized training process. We have kept the data. But however, there's another concern is about the parameters, the knowledge maybe also can be inferred back to some of the data you do not share, right? So it is also, in that context, it's also possible to add additional layer before the central agent to share the aggregated parameters. We can also implement the noise addition to achieve differential privacy in terms of the parameters. Because of the much limited space of parameter compared with the local data itself, this noise is supposed to be much lower. So then we also implement this, but of course, based on how much differential privacy in terms of your outcome it is, we have to sacrifice certain level of the performance. But again, you can see even in the very high privacy preserving cases, we have clearly a benefit compared with the case that nothing will shared, while we still preserve the knowledge. A final piece of work I want to mention a little bit is a lot of discussions nowadays about the Joule Train for energy system. That's really critical. I believe and also fully agree with that for planning, monitoring, dispatch, and control purpose. However, because of we are even talk about national level of digital twin and for different stakeholders and our various users, how is that possible to get all the information, even high resolution, maybe kind of a real-time information, not to mention the past information, together and process them together? Is that feasible? And we are also, at least for the electricity system, it's also a time-varying system. You have the plugging of EVs and plug out, whether the central agent can process that. This is basically what has been implemented in the recent, in most of the talk I have been kind of following is still the thinking is a centralized coordinator or processor to collect information from different stakeholders and to make the digital twin and share that to everyone. It's definitely worked, but there are a few problems. One is the robustness or resiliency. If you have the central coordinator, there are always a risk we will lose this one. Even you have a backup one, okay? There by two, you still have a higher chance that we may lose them. Also for scalability problems, particularly for the centralized coordination, it's very hard to update your parameters. Any changes of the network, everything have to be changed, right? So this pretty much works for static system. Then how that can be worked is a big problem. Last but not least, that is basically the core, is the data privacy. Real-time measurement is required to do a centralized digital twin. But again, different stakeholders, if you want to do an energy system twin, would that be feasible in a sense? So one thing we have been looking at a little bit in this, again, is a distributed thinking. Instead of looking at the centralized coordination or centralized processing, can we process some of the data more locally and share the information among the agent in a sense that it's going to be a local based on your local and neighbor. In the sense of neighbor, it depends on, it can be a cross sector as well, to get into the global state, system state and system identification, instead of producing all the environment data of single user to the coordinator. It's also possible. We have developed this framework to look into a distributed train, I say, in the sense that, but everyone will have the whole information in this sense. Okay, there are some papers recently we did. It's the same story. I think in general is a distributed way. But of course, you may feeling have been promoting decentralized or distributed data processing, which is right, but also we recognize there may be pros and cons for these two approaches, right? We have make this for centralized one. It's in terms of optimality, they're more optimal in the sense that the single agent can make everything, right? But on the other hand, they have their problem of single point failure. They have the poor privacy. For decentralized one, in most of the case, you have to suffer to some extent about the optimality. And also we have to basically change the way that we operate system, as currently most of the case we use centralized coordination. But there are benefits about resilience and scalability. So which one should we choose? That's the question. But then they bring us to think about, do we have to choose? Can we have both of them in one framework? So that's the last slide. This very initial thoughts I want to just share with you is we are trying to looking at a framework where it would allow you to switching between centralized and decentralized framework. I mean, from the control computation perspective, in this way, we try to kind of take advantage of both frameworks. The basic idea we are having now is for the normal operation conditions where everything is fine, you have very high resolution, a high bandwidth of communication, and very enough resources, processors are fine. Okay, we can doing a centralized way as shown on the top. It's going to be a centralized coordination for devices. Well, if something happened, either a cyber attack or destroy of the control center, or physically, or communication failures, then we can switch that to a distributed, decentralized, more autonomous system where you benefit more from this resilience, right? For normal condition, we can more optimality. For extremes, optimality is not the top priority. We can look a bit more on resilience to survivability, right? So in this framework. Of course, if you're looking at more local setup in a sense, it's even possible to do this without investment. So basically, here the framework is to say we should use distributed framework as a backup to centralized, instead of have two centralized controllers, another as a backup. We can have the distributed framework as the backup to increase your resilience. If you are looking at more like the wireless communication, where local area coordination, in fact, most of the controllers, they communicate with a central controller. They can also switch by using device-to-device communication to form autonomous or new communication layers. So in this sense, we do not need to invest in terms of the backup solutions, right? Because they can automatically shifting from communication with central controller, if you are doing wireless communication, and to shifting to talk with their neighbors to maintain resilience. So this is a very initial thinking, but I think it's probably worth to discuss, because I presented one, the centralized data management and decentralized distributed. And you may struggling to choose, and now we also to have this concept. Also, maybe you don't have to. We will continue doing this, and share that more. The last bit is about, even though we can provide the privacy preserving for consumers or for data owners, this does not mean they will share the data, because they know the data have value. They want benefit from it, right? So then we have to value the data. So one thing we have been in mind, because now if you look at the retailer tariffs, I don't think I see anyone, if I provide the data, another guy do not provide, I will not have an advantage for me, right? Then in that sense, why I should provide this data to the retailer which have lower operational benefits costs. So in this sense, we think we should join the energy and data as a joint market where we should distinguish people who share data, who share different level of data, and the people who do not share. So that this is the way that's really promoting the data sharing concept. There are many recent works on kind of pure data markets, but because of the particular applications in energy markets, there we are looking a bit more on how we can develop a joint market which can simultaneously clear the energy or data either as two prices or single prices based on whether you share the data or not. So this is somehow maybe tended to a bit more on kind of energy as services, right? For the same amount of electricity, depending on you provide data or not, you may have different prices, right? That's the concept, but it's also very preliminary. I hope next time we can bring a bit more news. So to summarize, access data, I think we all agree it brings different operational benefits for the energy system, which is critical for the decarbonization. However, some of the data, I only mentioned the consumer data, but it's same for industry. Some of the literature has demonstrated for industry data, you can use that data to identify their manufacturing process. Sometimes that is a kind of very commercial sensitive information, right? So some of the data actually embedded a significant amount of personal commercial sensitive information, while currently the majority of the consumers are not aware those kind of information, but they will tend to share less, which means we have to introduce mitigation techniques, which is the privacy preserving one. I mainly discussed the two options. One is we want to, if we trying to do still currently framework a centralized data processing, differential privacy is one promising option, which added the privacy, added noise into data to provide privacy. But the key is to understand the trade-offs. We just started a very preliminary analysis, but more need to be understand what is the right level of DP, what will be the right balance for energy application. That's no one have answered that. Another thing is whether we would like to be more disruptive changes to change the whole framework into more distributed data processing by utilizing edge devices, so that we can to share the knowledge we want to share, but not the data which have all the information which may not be relevant for some applications in that context. So the last but the part is probably we need a hybrid and coordinated data processing framework. This central decentral coordinate kind of transition is something we believe is really promising. The last bit is we need incentives. We can provide privacy, but still in the end, the consumers who we need to distinguish people from providing data or not, they need to be rewarded. I think that's all I want to share. It's quite a lot of information. I hope I didn't take too much of time. I really look forward to having discussions. Thanks for everyone.
Thank you very much. That was brilliant. So we've got already plenty of questions in the chat, so I'll go straight to those. So Andrew asks about the fact that the current structure of smart meter data communication is via the DCC, which means it's centralized. Do you foresee the use of other communication mechanisms to give the options of keeping data local? And I think I have a follow-up just to that as well.
Yes, I think in this way, it's actually, I mean, how can you see that? I think now for this DCC processes, if we enlarge its capability, it's actually a really good place to maintain privacy, because the DCC is a government body, people trust it. If we maintain this DCC framework, because now they don't see any data, they only collect the data and share the data to the retailers or who request it. But if the DCC expanded to allow them to processing the data before sharing, I think that is a fast and a quick approach to achieve the differential privacy. But of course, if we're looking at more distributed frameworks, I believe there may be much more radical changes. But DCC still can play a role as this, because with most of distributed data processing, we still need a central coordinator to share knowledge. But this is more complex. I mean, in that context, I cannot really offer currently what would be the best communication infrastructure. But I still believe either way, DCC will be, somebody like DCC is required to coordinate, no matter it's data sharing or knowledge sharing.
Brilliant. Jane just notes, by the way, that the DCC does not hold the data, the meters hold the data. Yeah, so I've just quick follow on that, because of the federated learning, it's a really interesting example. Obviously, it seems you were looking at quantile loss, which suggests probabilistic models.
Yeah.
So I guess one question for me is that obviously this requires quite a lot of computation then on individual households. So there's maybe scaling issues and computational issues there as well. So is there issues in actually implementing these things on thousands of households?
Yes, that's a valid question, a good one. In terms of, local processing, I mentioned we need radical changes. Now the smart meter data can do a bit processing, but they won't be able to do this level of model training. We need edge devices, or there are companies now to develop an enhanced version of smart meter, which have much more processing power. But in general, I believe because the computation will become very, very cheap, and also combine that with IoT devices, and there will be requirement there as well. By leveraging them together, I believe there is a way to really to kind of let's say efficiently upgrade the system. But again, now currently household cannot do that. More cost analysis probably required, but because of the reduction of the computational processing, the chips, I think that can be potentially applied. But another thing you mentioned, there are different levels of federated learning. You mentioned more on kind of device level, but if you look at for more commercial application like Google, they have used that thousands, millions, even much more of the company in their smartphones. I would suspect that in terms of, local processing or coordination, there have to be some solutions applicable on this. They call that's cross device learning. Then and they are also the you're right. It also have the synchronization problem. If you're looking communication and so on, your training maybe not necessary. We can get the information at the same time. Then there are kind of optimization method to deal with the kind of asynchronized different round of information to utilize the federated learning. Yeah.
Okay, thank you very much.
Steve.
Atez asks, thank you very much for the presentation. How do you think consumers can be incentivized to provide their consent and sharing their data? Do you think the proposed forecasting methods can provide benefits not only for the energy providers, but also the consumers, such as decreasing their costs, especially with the turbulent times we're in?
Yes, I think that's a valid question. That's also the one where we have been thinking over the last two years or so, why consumers want to share the data. But it's complicated. First, we need to understand what's the benefit, the value of data. Even that is not purely understand individual's contribution to the data, right? To kind of applications, and then that's whatever machine learning or some data analysis you did, you have to link with them. Where really money comes from is the energy market. So I think there are steps we need to somehow link the data with energy. That's energy market, which is effectively where every economics really kind of realized that's the energy market. So in that sense, we need a framework to do it. No matter it is a real-time framework or maybe a retailer pricing, they have to distinguish people share the data or do not share, maybe by offering a discounted, let's say, a price. I don't know if that, regulatory is that allowed or is there a provision on that, but I think that is a way to incentive to have to separate the people who share their data or who do not, because I think now most of the retailers do not distinguish. If we are in the same tariff, you share it or not will not change how much I pay. But of course, if you have to do this time of use tariff, maybe that's a different story. But for the same, like without time of use tariff, they should be distinguished the consumers by different sharing options or level of privacy levels they request. But of course, that's a lot more work. That's very recent. The data market concept. There are some colleagues are doing that, but I think they're quite interesting topic. There are a lot of problems there to investigate.
Thank you. And so, like, moving on from some sort of more domestic customers, moving to sort of the DNOs, David asks about, there's no reference to SCADA or DMS in the briefing paper. How do you propose that DNOs benefit from the access to the data you're prescribing? Noting that SCADA at DNOs includes the N-2 resilience and N-1 location security.
Yes, so we are looking at if you have the SCADA system, which if you deem that as more operational data, that is outside of smart meter. I mean, this regulatory framework. But I understand for DNO you have problems about the visibility. Even your SCADA system cannot cover the very low voltage of information that you would be interested in. One option is you install all the meters yourself in the aggregate level. But another is one of the examples we mentioned. If you are interested in kind of voltage forecasting, sorry, it's a bit noise. If you are interested in voltage forecasting, it's potentially use these federated learning approaches to access the consumer data. And understand the DNO, they have the right to access the consumer data in the aggregate level. But in this sense, for the federated learning applications, that may be an easier way for aggregation instead of aggregated data. But another element you mentioned about the kind of reliability. I think for reliability events, you are definitely right. You don't need a distributed processing. You won't lose 99.99% chance you won't lose two. I mean, you have a backup, you won't lose that. But what we have been proposing this switching, let's say if that's something you're interested in, is in a more on resilient perspective. At some extreme events, I think it's unpredictable. There will be very small chances that can happen, even you have a backup operation center. So in our proposal is whatever, I mean, even in the very worst cases, this is a potential solutions. So by switching the processing to a local processing, well, majority of cases you still business as usual in the very rare you'll have this. Particular for DSO, if DNO, if they have the use in a local communication area, you rely on, for example, wireless communication I mentioned. But for national system, we haven't think about how to make that work. But for local area, maybe kind of microgrids or slightly larger, you don't need to invest anything. If I believe we will gradually rely on 5G or wireless communication. You don't need to invest because all these controllers can talk with each other while talk with the base station. But definitely we need to understand a bit more on the practical applications. But I think that's something DNO might be benefit.
Thank you very much. We've got plenty of questions still. We've got 5 more minutes as well, so add further ones. Julian asks, and I guess this might be related to the energy markets, I guess, so maybe interesting to hear. Okay, but he talks about what's your best strategies in implementing privacy tools in the future if there's several providers. So you've got several companies, different points in the chain, different countries, or even the same provider that has some point changed its strategy. Will the data analyst need to know from each source which level of noise was used or which distributed tools to use, or recommend a standard that everyone should use? So it's quite an interesting question about how you'd integrate these things.
Yes, that's a good question. We haven't really we considered one data kind of user with different owners, but we haven't considered we have different data users, how they coordinate. I think one way potentially is to without sharing it again. This kind of local, we might be considering more local data processing. They have their own requirement for different suppliers or owners. By collecting their data, then they learn the knowledge from that and then share the knowledge instead of directly share data which have different noise addition or different level of protection. But I think there is a more even wider question that also was asked when we launched this white briefing paper is energy data we cannot look at in isolation. This energy data is only part of the data. You have so many kind of transport data and IoT devices. How we can do a kind of coordinated development of, I mean, GDPR is one of the governing body of this privacy element. Do we need more, or is for each sector to decide? I don't have I cannot have offer answer, but I think that's really a good exploration. No matter it's the same energy data have different owners or have different sectors, how we can provide a coherent preserving techniques or standards to do that. But one particular thing I mentioned is the privacy attitude are really diverse. It's even more diverse than the attitude for energy costs. So the standardization can be very challenging for everyone. If we use one single standard about kind of certain level of DP, it also depends on the privacy kind of the benefit part. I mean, from academic perspective, I would promote more liberal kind of a way of really allow the user and owner to buy through a market environment to review the true privacy concerns and the benefit. But for practical, I think there may be more have a bit more investigation on that. Thanks for the question. We'll also think a bit more on that.
It does feel like there's a place to try and investigate this deeper and find out where practical limits are as well on some of these places. Jane asks, thank you for the talk, which is fascinating. What is your view on the DCC other user role, which provides third-party access with consumer permission to the data? And please note that we are a DCC other user, Hildebrand.
So yeah, I mentioned I think a DCC have a really active role. I mean, or something like DCC. We need a central coordinator in a way to manage all the consent and everything. But one thing we really want to basically promote is we find it's really hard for third party to access the data, because I mean it's really hard to express the concerns of users. One thing we have been in mind thinking a bit, maybe not directly related to this question, but we are thinking how can we define a threshold of privacy preserving which they can get out of the consent requirement. The consent is really great. It's also show the users have a active role to play to manage their data. That's the basic part of the privacy protection, privacy definition. But also, it's really hard to make the data access really hard. Can we do a bit more balanced approach where define certain level of data that can be directly accessed for third party? I think that will be very interesting and really promoting the wide access. So, but then again, I have to like US Census, for example, that's the example we give. There are a lot of information, but after the certain aggregation, the public entity, for example, they can utilize this data without asking the consent, right? So then there should have some definition about at which level those data can be accessible for the third party, or like US and Canada, they have one option for the user when they decide they share the third party or not. They have the option to share the data in anonymous way, right? So basically they give this, once it's anonymized, they give away a certain control, but they can ask back. Definitely, they need to control their data. But in that way, that will promote a bit more on a wider data access. So that's just all the thinking we have, but it's really I think too interesting to explore.
Okay, there's two last questions. I think quick ones relatively here. So and we'll finish there then. So David asks, so you did mention phasor measurement units, PMUs, earlier. Obviously they weren't in the report though. I guess, you know, is there comments on PMUs and obviously ditto voltage? David says, you know, about sort of privacy arrangements around those sorts of things.
Yes, so PMU, this again, I think yeah, we'll be looking to be more on kind of operational data. I mean, in terms of, because this report is more on consumer level, so we don't have the PMU. PMU is in a sense that is already aggregated data, which I believe by definition, it's already not belong to the consumer. That's belong to the DNOs to utilize, to decide. But for very low voltage, again, it depends on whether we want to utilize the smart meter data at individual household level or not. If we want to utilize that to replace or to reduce the reliance on installation more this PMUs or other metering devices, then that will link with the privacy kind of consideration. But again, this current regulation requests the DNOs to provide a privacy protection plan. Then they can utilize that. They can directly access the data without third party, without consent. So in that case, I think it's really interesting from DNO perspective, also for our perspective is, or even maybe regulators, what is the right definition, or what is the right privacy plan to consider in this way to balance the utilization and the value. But now I think currently most are based, which is, I mean, a way to provide privacy, but in the sense that there is no mathematical guarantee how many of that means what of aggregation. But that's already something I think beneficial for the consumers. But it's really good to look at how can that be combined maybe with differential privacy, for example, in addition to the aggregation. So what would be the meaning for the DNOs?
Great. And the last thing from Andrew is, do you see higher time resolution meter data, say 1 minute rather than 30, becoming available to help with constraint management and flexibility services?
The smart meter can do that. The smart data, I think, even more right, is 10 seconds or 1 second. They can mirror that level of data, and then in that context, if we want to access a higher resolution data, then there will be if you want to do that real timely, then there will be communication problems. I don't think that going through the DCC and come back, they will make that. So you need to have other way of accessing communication layers, because they do have this kind of consumer access devices which can bypass DCC directly, provide data, but that's a big problem I don't want to enter into today. But in that sense, I think it's possible by utilizing wireless communications really to share high resolution data. But I think there are a few things. One is the communication, whether the communication can do that, whether the delays would make it useful. But a more bigger question is what the benefit of that from the DNO perspective, whether if we can quantify the benefit of that and big enough to consider this. I think there will be ways to doing that. And also one of the work we are doing is kind of cloud edge computing basis. So probably if you access or you collect all the high resolution data in real time to one point for the DNO to process, it's also probably not practical. So that's use some edge devices in different level to capture information and then share that. Maybe a more feasible solutions in terms of the computation, communication burdens and also high resolution data. Yeah, we are keen to discuss a bit more if we have a project supported by EPSRC and Siemens to look at how can utilize cloud edge framework to really manage very high resolution demand side response data.
Thank you. And Jane does confirm here that with the communication access device, you can get the smart meter data 10 seconds and the gas data at 30 minutes. And you can only add the CAD if the verification and consent is in place via the DCC. So brilliant. Well, thank you very much, and thanks for all the questions and everything there. If you have any, Fei, you're happy to take any further questions. Your email is there, so feel free to email Fei with any further follow-ups. It's been a really interesting talk. We'll also share the slides, and this recording will be shared on our YouTube page shortly after as well. But I wanted to first say a final thank you to Fei Teng for a really interesting and deep talk about lots of the issues facing getting this data out there, which is everybody wants to get access to this really valuable stuff. So yeah, thank you very much, and yeah.
Thanks,
Looking forward
Steve,
to seeing
for
what
organizing this.
future
Yes,
work.
thanks, Steve. Yes, and thanks everyone for joining the talk, and look forward to any questions, any discussion you may have. And also, I want to acknowledge I forgot that's all the contribution from my student and postdocs to make this available. Thank you, everyone. Thank you.
Brilliant. Thank you very much.